Hey friends, welcome back to the Rad Stream. I want to continue my exploration, I'll call it, into OpenAI's endpoints and what it means to fine tune a model. I think I have the basics down. Like I have the kind of basic understanding of how to interact with this technology. There is what's called a model, which is, and Chat GPT is basically a front end, an interface to interact with those models, right? That give you the AI's response to whatever prompt you give them. But what I'm interested in learning a little bit more about is like how do you customize those responses? ChatGPT has been trained to give a very broad general response to a prompt or a question, but you can use the underlying model, which is I think is DaVinci for ChatGPT. They actually haven't said it. I think it might be a combination of all of the different language models that they offer. Um, but how do you fine tune that for your own use case? I had a conversation with Kelly Claus earlier this week, and she was interested in learning more about that as well for her own use case. Wrote, and so it kind of sent me down a rabbit hole of learning more, and it's kind of like this is kind of an interesting area, I think, even for the no code people, because like who's going to be at the intersection of open AI and bubble, for example, right? Like this is an interesting area to be in. The bubble interacts with this, with these endpoints very easily. These endpoints are not hard to connect to, and I watched a tutorial today on someone who did this in I think VS Code. Oh no, React. He did it in React, and it was like there was so many extra steps. Right, I'm looking at it like watching him create. Like it made me appreciate Bubble, reappreciate Bubble, because like all the steps that it took to just create a simple input and a button, and do that API call. There was like so much to it. Right, it didn't take him very long because he's very not knowledgeable about how to work with HTML, CSS, and JavaScript. But like I imagine the years that it took him to be able to do it that fast, that was probably a lot of effort, right? So again, what I want to see is like how much of this can you do just through Bubble? Do you need to implement code at some point in order to fine tune a model or train it for your specific use case? I'm hoping that's not the case, because I'm hoping that I can do all of this stuff from Bubble, um, just with communicating through the API. So with that, let's take a look at what the documentation says. Again, I'm back in here, fine tuning, learning how to customize a model for your application. And again, there are so many different use cases for these open AI endpoints, that the possibilities are endless. So again, someone who is familiar with this, I think it's a good thing to know, because like this has only been out for what, a month, and like there's going to be a ton of software that is going to be able to use what these AI models output. Right, the possibilities are endless. So somebody who knows this stuff and knows how to use it, I think, is going to be in a good position to, I don't know, sell their services, or like just be knowledgeable about um, how to use these endpoints. I guess somebody could make money off of that. All right, introduction. Fine tuning lets you get more out of the models available through the API by providing higher quality results than prompt design. Ability to train on more examples that can fit in a prompt. Token savings due to shorter prompts, and lower latency requests. Okay, so breaking this down a little bit, in my understanding, again, I'm learning this. Like I'm not pretending to be an expert here. I'm learning this stuff as like I'm kind of learning it live, I guess. Right. So my understanding is that the higher quality results than prompt design. I'm not really sure what prompt design, what it's comparing to here, but higher quality results, I think what they mean is like more targeted results to your use case. The ability to train on more examples that can fit in a single prompt, right? So you can upload a JSON file with multiple examples of prompts that will train the AI algorithm to give you a more response that's tailored to what you're asking it, as opposed to ChatGPT, which is just very general. Token savings. Tokens are like the number of words or characters that go into the prompt. Prompt, again, just being like a text input, like you're like, how old am I would be a prompt. And like how many letters and characters go into that. It amounts to it. The AI counts it as tokens. They're called tokens for some reason. It roughly equals 1 word per token, but it's not exact. And lower latency requests, I imagine that means that it is just faster because it kind of knows what to expect. You're training it so that it gives you a faster, more targeted response. So that's how I'm going to interpret that. GPT-3 has been pre-trained on a vast amount of text from the open internet. Makes me wonder, is it online now, or is it trained on information that was available on the internet at a specific time? I don't really know. When a given prompt with just a few examples, it can offer into it what task you are trying to perform and generate a plausible completion. This is often called few-shot learning. Let me read that again. When given a prompt with just a few examples, it can often intuit what task you're trying to perform and generate a plausible completion. This is what we call few-shot learning. Okay, that's what ChatGPT does anyway, though. So, I'm not really sure what, well, maybe this is just describing ChatGPT. Fine-tuning improves on few-shot learning by training on many more examples than can fit in the prompt, letting you achieve better results on a wide number of tasks. Okay, so again, just kind of like what I'm understanding is like you're pre-training it so that a single prompt in the future, let me say it again. You're pre-training it with prompts now so that in the future it will give you a more targeted and tailored response. Once a model has been fine-tuned, you won't need to provide examples in the prompt anymore. This saves costs and enables lower latency requests. At a high level, fine-tuning involves the following steps. Prepare and upload training data. I want to see like what the example of that training data is, right? Like what is the training? How do they expect that to come in? Train a new fine-tuned model. So yeah, this is something that I've been like wondering, like, is it, so say I'm training the base model that I'm working on is DaVinci, right? Like, do I then get like my own version of DaVinci that I'm fine-tuning for my use case? It has to be, right? Like it has to be like a unique URL, I guess, that, like is just my newly trained model, right? Isn't that the only way that makes sense? I think so. Use your fine-tuned model. Obviously, you'll want to use your model after you've trained it. All right, visit our pricing page. I'm not going to visit pricing. I don't care about pricing right now. I just want to understand this stuff. Installation. We recommend using our OpenAI command line interface to install this and run. Pip install upgrade AI. The following instructions work in. I hope I don't have to use a command line interface, but if I do, I'm sure I'll figure that out at some point. I know that Olivia Look did this in Bubble already. She built a workflow to upload a JSON-L file to be more specific. So I'm hoping that this can all be done from Bubble. Set your OpenAI key environment variable by adding the following line into your shell initialization script or running it in the command line before fine-tuning the command. All right, so you're just adding the API key. So this is kind of is it just an API call? It's not an API call, I guess. I think you're uploading. That's probably the difference here. All right, prepare training data. Training data is how you teach GPT-3 what you'd like it to say. Your data must be in a JSON-L document, which looks like this. I just learned what a JSON-L document is, and it's pretty much just a single. It's a a JSON file, but every line is a JSON object, right? Usually you'll see this kind of indented and below each other. If there's array, you'll see square brackets, and that kind of goes down multiple lines. This is a full JSON object in one line. And that is the format that this is expected in. Training example, you can use our CLI data preparation tool to easily convert your data into this file format. Designing your prompts and completions for fine-tuning is different from designing your prompts for use with our base models. Okay, so that's something new to me. I didn't understand that. Designing your prompts and completions for fine-tuning is different from designing your prompts for use with our base models, DaVinci, Curie, Babbage, and Ada. Those are the base models. In particular, while prompts for base models often consist of multiple layers, multiple examples, few-shot learning, or for fine-tuning, each training example generally consists of a single input example and its associated output without the need to give detailed instructions or include multiple examples in the same prompt. For more detailed guidance on how to prepare training data for various tests, please refer to our Preparing Your Dataset guide. All right, I guess this is probably like, this is probably where the bulk information is going to be. Data formatting, specific guidelines, classifications. There is a lot to this. Company prompt, reliable accountants. Okay, so this is an example of a prompt company. Reliable accountants. Best advice in town. All right, maybe I'll jump back and forth between that. So there is a specific format for how they want this. We develop a tool which validates, gives suggestions, and reformats your data. The tool accepts different formats with the only requirement that they contain a prompt and a completion column key. All right, and that's what this looks like, right? We've got the prompt text and then the completion. Right, so this is what you're putting in, and this is you're telling it what the ideal generated text should be. You can pass a CSV, TSV, TLSX, JSON, or JSON-L file, and it will save the output into a JSON-L file ready for fine-tuning after guiding you through the process of suggested changes. The following assumes that you've already prepared training data following the above instructions. Start your fine-tuning job using the OpenAI CLI. Where base model is the name of the base model you're starting from, Ada, Babbage, Curie, or DaVinci, you can customize your fine-tuned model name using the suffix parameter. Running the above command does several things. So this is the command. It doesn't look like it can be done through the API. Maybe it can. I'm not sure. This is definitely the command line, though. Uploads the file using the files API, right? Can't you do that just through the API instead of doing a command? Creates a fine-tuned job, streams events until the job is done. This often takes minutes, but can take hours if there are many jobs in the queue or your data set is quite large. Every fine-tuning job starts from a base model, which defaults to Curie. The choice of models, the model influences both the performance of the model and the cost of running your fine-tuned model. Your model can be one of Ada, Babbage, Curie, or DaVinci. After you've started a fine-tuned job, it makes them take time to complete. Your job may be queued behind other jobs on our system, and training our model can take minutes or hours. All right, use a fine-tuned model. When a job has succeeded, field will be populated with names of the model. You may now specify this model as a parameter to our completions API. That's what I was looking for, right? So I guess, do you get a special name? After your first job completes, it may take several minutes for your model to become ready to handle requests. If completion requests to your model timeout, it is likely because your model is still being loaded. This happens. you can start making requests by passing the model name as the model parameter of the completion request. Okay, so the model name, do you set a I don't know how you set the model name though. That's the part that I don't really understand here. How do you get that? Maybe it just gives it to you after you've uploaded this. Maybe it just gives you the name of the parameter to pass so that you're looking at the right model. So it's still looking at the same model. I think how it uniquely identifies your model or your version of this model is by this parameter that you're passing through. That seems to be what I'm understanding here. But I don't know where that comes from. That's not clear to me where that parameter comes from or when it gets created. Oh, maybe this is it right here. When a job has succeeded, the fine-tuned model field will be populated with the name of the model. That's probably it. Okay. All right. It gives you this response here. You can delete a fine-tuned model. It honestly doesn't seem all that hard. These commands, even if I did have to, I'd love to not have to do these, use a command line just because I'm not familiar with it. I'd love to be able to do this from Bubble, and I think you can, like I said, because it seems like even though this is from the command line, it's still just calling the API to create these jobs, as they're calling them. So I think that I still can do this from Bubble. It just has to be in that JSON-L format that they want. All right, let's just take a quick look at preparing your data set. I'm not going to dig too deep on this tonight, but I do want to just get a sense of this. And is that just this part here, preparing your data set? Oh, it just took me to find out. It's the same thing. Okay. Let's look a little bit at preparing your data set. Fine-tuning is a powerful technique to create new models that's specific to your use case. Before fine-tuning your model, we strongly recommend reading the best practices and specific guidelines for your use case below. Data formatting. To fine-tune a model, you'll need a set of training examples that are each consistent of a single input prompt, but an associated output completion. This is notably different from using our base models, which you may input detailed instructions or multiple examples in a single prompt. All right, so yeah. You have to give it the input and the type of output that you're looking for. That's what it's expecting in this format here. In this format here. This. Your prompt, and then your ideal completion for that prompt. And then it'll learn from that. It actually learns from that. The thing is, I just don't know how many to do. Like how many examples do you have to give it before it starts giving you something useful? I wish there was more info on that. Maybe it's coming. Each prompt should end with a fixed separator to inform the model when the prompt ends and the completion begins. A simple separator, which generally works, is this. The separator should not appear anywhere else in the prompt. Each completion should start with a white space due to our tokenization, which tokenizes both word with the preceding white space. Each completion should end with a fixed stop sequence to inform the model when the completion ends. A stop sequence could be, okay, this is just indicating where the prompt is starting and ending. Is that being done here in their example? Doesn't seem like it. No, doesn't seem like it. Oh, it's done here, down there as an example. All right, cool. For inference, you should format your prompts in the same way as you did when creating the training data set, including the same separator. Also specify the same stop sequence to properly truncate the completion. I have to say that this documentation is written, I think, for such a complicated subject as AI training or just AI in general. This is remarkably plain English, right? I think they've made it as easy as it is going to get for somebody who's interested in learning this. Yes, of course, you need to have some kind of technical background to be looking at this, but a lot of this is learning. Like a lot of this is just learning their terminology and like the broader framework for what this does. I think everyone's kind of learning that at the same time. But it's like this isn't so jargony, right? I think maybe that's I'm used to such jargon, like technical documentation that's just completely unapproachable for somebody who doesn't already know how to work with it. This is like shockingly uh, basic English to me, and I appreciate that. Fine tuning performs better with more high quality examples. I'm looking at some best practices now. To fine tune a model that performs better than using a high quality prompt with our base models, you should be able to provide at least a few hundred. There we go. All right, so I got the answer to my question. You should be able to provide a few hundred high quality examples, ideally validated by human experts. Who a human expert. From there, performance tends to linearly increase with every doubling of the number of examples. Increasing the number of examples is usually the best and most reliable way of improving performance. Classifiers are the easiest models to get started with. For classification problems, we suggest using ADA, which generally tend to ADA is one of the models, which generally tends to perform on only very slightly worse than more capable models once fine-tuned, whilst being the significantly faster and cheaper. All right, how deep do we want to go here? This is a classification prompt. Let's do at least one of these. I'm going to take a look at least one of these. In classification problems, each input in the prompt should be classified into one of the predefined classes. For this type of problem, we recommend using the separator. We talked about this already. Case study. Is the model making untrue statements? Let's say you'd like to ensure that the text of the ads on your website mentions the correct product and company. In other words, you want to ensure the model isn't making things up. You may want to fine-tune a classifier which filters out incorrect tabs. The data set might look something like this. Okay, so company, VFF Insurance, all-around insurance, one-stop shop for all your insurance needs, supported, completion. Oh, this is one line. Company loft specialist, product, edge straight teeth in weeks. Supported completion, no. So you'd have to give it a whole bunch of examples, I guess, like this. Is this the same prompt? Is this two different prompts? It is two different prompts. Let's see if I can got that. Maybe I'm missing something. Maybe it's getting cut off there. See what this looks like in a text document. Oh, okay. That's the part that I couldn't see, right? This is completion. Yes. This is an example of what you would want, and this is what you're feeding into the API call, and this is an example of what you don't want. Product specialist, loft conversion specialist, edge straight teeth in weeks. So you give it an example of what it is not, too. I don't know why they use two different loft conversion specialists. I don't know why they use two different companies here. I guess it's just giving it more examples. The more, the better. In the example above, we structured an input containing the name of a company, the product, and the associated ad. As a separator, we used N supported. As a separator, we used N supported this. Which clearly separated the prompt from the completion. With sufficient number of examples, the separator doesn't make much of a difference, usually less than 0.4%, as long as it doesn't appear within the prompt or the completion. For this use case, we fine-tuned an ADA model since it will be faster and cheaper, and the performance will be comparable to larger models because it is a classification task. Now we can query our model by making a completion request. This is the completion. It doesn't give you your fine-tune model. Here you go. Your fine-tune model. That's how you know you're looking at your model. And then the prompt is company, reliable accountants, LTD. Best advice in town, which will return either a yes or a no. All right, so this would give you a yes or a no. A yes or no. How would that be helpful? Is reliable accountants the best advice in town? Is that what you're getting the yes or no from? I don't know. All right, let's look at one more. Let's say you'd like to get a degree to which a particular tweet is positive or negative. The data set might look something like the following. Oh, that's a little bit more. It's a little bit more relatable, I suppose. Let's see what that looks like. All right, the prompt: overjoyed with the new iPhone. Completion is positive. Prompt: Lakers disappointed for a third straight night. Completion negative. Okay. Once the model is fine-tuned, you can then get back the log probabilities for the first completion token by setting log probs equals 2 on the completion request. The higher the probability for positive class, the higher the relative sentiment. Now we can query our model by making a completion request. Excited to share my latest blog post. I guess that would evaluate to a positive. Tokens positive. Yep. Okay. All right. So a few different, and this is a categorization for email triage. I guess you can categorize this through the endpoint too. All right. So I'm starting to see a pattern here, right? Like if I'm zooming out for a second, I'm starting to see the pattern. I think the logistics of how you upload this JSON-L file. Yes, that is going to require a little bit of learning, but the basic logic here starts to make a little bit more sense to me. You are sending examples of a prompt and the expected completion, which will fine tune the model, tailor it to your use case, and then you can keep calling that endpoint via a parameter. Then that will continue to give you the more targeted response, right? So a way to interact with the underlying AI model for your own use case. So again, I don't know that I wonder if anyone is really like an expert on this yet. I feel like we've only had access to it for a month, and we're just kind of exploring it still. But I do like the way that they've put it out here and put this documentation out for just anybody who wants to access it to learn. It's like super cool that it's so open AI. So I think I'm just gonna like sporadically continue to look at this documentation and start doing. I also created that image generator using the what was it, the image generation. I think that's DALL-E, the DALL-E model creates an image out of a text prompt or another picture. And that was pretty cool. That was pretty easy. I don't know if you can train that model. I'm not sure. But yeah, I'm going to continue seeing what else there is to learn about this stuff and build some AI generated logic into an app and see how that's useful for Bubble, right? I think that or Bubble use cases. I think that there's a lot of different use cases for this that we're still kind of like exploring. Like, what is even the best? Like why would you need this? Why would you need this stuff? Um, but I think as time goes on, it's just going to be more and more that more apps are just naturally going to have some type of machine learning or AI underlying integration to it because it just makes life easier. It does. All right. I think that's all my thoughts on this for tonight. Again, I'll check in tomorrow. Bubble released a new ultimate guide to no code, which I'm really curious to read. I'm going to check that out tomorrow, probably around 1 p.m. And I will 1 p.m. Eastern time. I'll be back tomorrow, right? The Rad Stream. Thanks everybody for joining. Catch